Hi friends, in the last video in this chapter sound, we learned the units of the frequency and units of time period. Now we are going to learn how can you represent graphically, the displacement and time of a simple pendulum. The motion of the simple pendulum graphically plotted against the displacement and time. That is, let this is be the simple pendulum. This is be the pendulum. This is the bob of the pendulum. In the last video we learned this, and this is the bob. Now from the mean position, let this is the mean position P. Pendulum starts to move towards the extreme left position, that is the position A, and then back to the extreme right position, that is the position extreme right position, from extreme left to the mean position and reaches the extreme right position B and back to the mean position again. Then one vibration is said to be made by the pendulum. That means this shows that when the pendulum starts its journey from the mean position towards the left, then the displacement gradually increases. The displacement gradually increases as the time increases. When it reaches the extreme left position, then the displacement will be maximum. And when it backs to the mean position, displacement decreases. And when it reaches at the mean position, displacement becomes 0. And when it moves towards the extreme right position B, again the displacement increases. And when it reaches the extreme right position B, the displacement will be the maximum. And when it starts to back again, comes back due to the resistive forces or the restoring forces which helps to restore the motion of the simple pendulum, due to which the pendulum moves back to the mean position again and again. This is the one complete vibration of the simple pendulum. But how can you graphically plot this? Let's see here. Graphically we can plot this, and as simple pendulum execute the periodic motion, so the displacement from the mean position P to the extreme left A and from mean position to the extreme right B must be equal, since it executes periodic motion. Let the displacement D is plotted along the y-axis and the independent variable time is plotted along the x-axis. Now, as it executes the periodic motion, we just measure this. Now pendulum starts to move. Initially pendulum is at the mean position, that is the graphically position O. This is the mean position line, and when the pendulum reaches towards the extreme left position, now the time increases, the pendulum displacement increases. Now within a certain position, when the pendulum moves from this to P to A, let this is be the position, this is be the position, displacement increases. And when reaches at the extreme position A, let this is the position A, that is the displacement will be the maximum. Then what happened? Now pendulum moves back towards the mean position. Gradually the displacement decreases. When reaches at the mean position, now the pendulum moves back. Now the displacement decreases. Displacement of the pendulum decreases. At the mean position P, the displacement becomes 0. Displacement becomes 0. So now pendulum moves towards the extreme right position. Again the displacement increases, or the gap from the mean position to this again increases. Now we can graphically plot this as this. The motion of the simple pendulum can be graphically plotted. The displacement type graph of a pendulum. Gradually the displacement increases when the pendulum moves towards the extreme right position, and when reaches at the position B, that will be the maximum displacement, and then again decreases its amplitude, its displacement decreases, and when reaches at the mean position, back to the mean position, then again the displacement becomes 0, and it will be continuous, it will be continue its motion. As a result, now this is the maximum displacement from P to the A. This will be the maximum displacement. So this is called amplitude A. plus A. Similarly, this is the amplitude also, because it executes periodic motion. So this is the graphical representation of the motion of a simple pendulum, where A is the amplitude. A is the amplitude. Amplitude means the maximum displacement. The maximum displacement from the mean position of a vibrating body is called its amplitude. That is the maximum displacement. Max displacement from the mean position or the position of rest. From the mean position. From the mean position or the position of rest is called the amplitude. Now, in this graph, if we again draw another one motion of the simple pendulum that execute number of the vibrations in 1 second, that is periodic motion. This is O, this is displacement D. Now this remains same, this will be this. Now let this is be the first vibration of the pendulum, and time period will be T, as it will be periodic, so the gap will be same. The gap will be same. That means now it also execute periodic motion. This will be twice T. This is the graphical presentation of the motion of the pendulum, where the two complete vibrations are represented. First vibration time period capital T, second vibration 2T, and for the third vibration this will be 3T, and so on. So the distance between these 2 points, this is plus A and this is the minus A. This is also the plus A, that is amplitude in the first half, in the second half. Distance between these two successive crest, this is called wavelength. This is called wavelength. Or the distance between two successive trough, this is called also wavelength, represented by lambda. This is called wavelength. Another one important term, wavelength, represented by lambda. The distance between two successive crest or the distance between two successive trough is called the wavelength of it. In this video we learn up to this. Okay.